Let's talk about ionic compounds or ionic bond or electrovalent bond and electrovalent compounds. So this is the main type of chemical bonds. Among that there are three types of chemical bonds like ionic bonds, covalent bonds and metallic bonds. So in this video I shall be discussing only about ionic bonds, and before going to explain it, one thing need to understand that what is the reason of a chemical bond and why atoms will donate and or accept electrons, because every atom has the tendency to attain the electron configuration of its nearest inert gas or inert molecule like helium, neon, argon, krypton, xenon, radon, as because they have 8 electrons in their outermost shell, so that the other atoms, like in group number 1 to group number 15 or 16 or 17, they try to attain that electron configurations to be stable. So the main reason of chemical bond or forming the chemical bond is to get the stability, and that is why the atoms donate, accept and share electrons. Sharing electrons will be the discussions of covalent compounds or covalent bonds. But now in this tutorial about ionic bonds and ionic compounds, I shall be discussing about accepting and donating electrons. And most often that you need to know first that what is the definition of ionic bonds. And as students of English versions, Cadet College and anywhere from the world that you are watching this video, keep in mind one thing, that these channels videos is designed for only academic purpose, so that definitely there is a limitations in all lectures, because I'm just giving you the idea that till how much we can go, but you'll decide that till how much we should go. So if you see the definitions of ionic bond, that this ionic bonding is a type of chemical bonding. Of course, is a type of chemical bonding. The main keywords is that involves the electrostatic attractions. What is this? These electrostatic attractions, or we can say that electrostatic force, or we can say that Coulomb force, in between oppositely charged ions. So from where these oppositely charged ions will create? So as we'll be talking about ions, we need to know there are two types of ions, and these are actually the cations and anions. So we can say that first one is cations and the second one is anions. And I hope you know it already, because this is very easy. Cations means positively charged atom, and anion means negatively charged atoms. So when an atom will be positively charged, as because we know usually in an atom there is a similar number of electrons and protons. I mean, if there is, and suppose in sodium, we know that the atomic number of sodium is 11. It means in the atom of sodium we know that it has 11 proton in the nucleus and 11 electrons in the outermost shell. I mean, in the other shells. Outermost shell we have 1. So 2, 8, 1 is the electron configuration of sodium. So when sodium will donate 1 electrons, it will be a positive ions, which is a cations. And when another atoms will accept 1 or more than 1 electrons, then it will become anions. So we can say that cations is positively charged atom, and in case of anion we can say it is negatively charged atom. Okay, so I'm coming up with the idea. When cations and anions comes together, you know that that will be an attractions, and these attractions between these oppositely charged ions, it's called the electrostatic force or electrostatic attractions. When these electrostatic attractions will work, then we can see that this is an ionic bond, and this is a main type of bonds with within the metal and non-metal. This is very important. So ionic bond will form with metal and non-metal. Why? As because we know that group number 1, 2 and 3, these are called the metal group. As you know that in periodic table, in the leftmost groups they are metal, and in the rightmost group they are the non-metal, except the inert gas like group number 18. So group number 15, 16 and 17, they are mostly non-metal. So the metal group has low ionization energy, and the non-metal group, these atoms will have more ionization energy. So that is why the metal group is more prone to donate electrons to get the stable electron configuration like its nearest inert gas. And the non-metal group, they have more prone to accept electrons to get the electron configuration like its rightmost inert gases. And so that when two different type of, like we can say that group number 15, 16 and 17. So we have low ionization energy in this metal group, and it has high ionization energy in this non-metal group. So when it has low ionization energy, then it donates electron. When it donates electron, it becomes positively charged atom, which is called cation. So here it would be like positively charged ions or positively charged atom. This is called cations. And when they have high ionization energy, these non-metal group will have more ionization energy, will have more prone to accept electrons. And when they accept electrons, they become negatively charged atom, and these are called anions. And the attractions in between these two, then it becomes like that, X and Y. So when these two types and positively charged ions comes together, then there is an attraction force. It's called electrostatic force or Coulomb force, and then this bond will work, and this bond is called ionic bond or electrovalent bond, and the compound here is called ionic compounds or electrovalent compounds. So I hope you understand the very primary level explanations of ionic compounds. Usually the main thing is that ionic compounds will form in between the metal group and non-metal group. And metal groups like group 1, 2 and 3, they have fewer electrons in their outermost shell, and then they have more prone to donate this electron, and they will become positively charged atoms, and the non-metal group will become negatively charged atoms, and then they will bind together, and there is an attraction in between these ions. These are called electrostatic ions. Right now I want to give you some idea. I hope you understand. And now you see some very common metal and non-metal group. Very common, that is usually discussed. I'm not going much detail, but as it is a very primary level lecture, I'm giving you some idea which is already in the books, but students of English versions, Cadet College, and wherever you are right now is watching this video from any corner in this world, please, if you're for the first time that's studying ionic compounds, try to understand more about it. So metal group, like we can say that sodium, we know it, potassium, lithium, even rubidium, cesium, francium, though it's not very well known, and then magnesium, calcium, aluminium, copper, zinc, iron. So these are very common metals that usually, like even mercury, stannum, lead, whatever. Let's discuss about these things. Sodium, there will be sodium plus iron, magnesium plus, potassium plus, lithium plus, and in case of non-metal, let's think about oxygen, fluorine, even like chlorine and bromine, even iodine, whatever. So when we think about it, now you think that the electron configuration of oxygen, if we see that we have oxygen has 6 electrons in its outermost shell, but chlorine, fluorine, bromine, iodine, as their group number 17, they have 7 electrons in their outermost shell. So these atoms will try to have at least 1 electrons in their outermost shell, and then they will become like neons. So like no, neons actually, fluorine, neon, and then chlorine like argon, and bromine, and then krypton. So they will try to get the electron stability like their very near inert gases. So as fluorine is prone to accept 1 electron, so it will become F minus, chlorine become minus, bromine become minus, iron become minus, but oxygen will become 2 minus, as because oxygen will accept 2 electrons. But now in case of sodium, we know that sodium, potassium, lithium, copper, zinc, iron, like in this case, they can donate 1 electrons. So they will become sodium plus, potassium plus, lithium plus. But in case of magnesium, magnesium has 2 electrons in its outermost shell, so magnesium will become 2 plus, calcium 2 plus, aluminium 3 plus, copper 2 plus or even 1 plus, zinc 2 plus, iron 2 plus, or even iron can be 3 plus. So now you see these positive ions, why it has been created? Because they usually try to give electrons, usually try to donate electrons to the non-metal. So the attractions between metal and non-metal are called ionic bond. Now you see, which is very common, like in case of lithium. Lithium has, this is the nucleus, this is the first shell, and this is the second shell. So you see that when lithium's in first shell it has 2 electrons, and the second shell it has 3 electrons. As you know that lithium, the atomic number of lithium is 3. So when these outermost shell electrons will be gone, then we know that in the lithium atoms it has 3 protons inside, but only 2 electrons, because it has already donated 1 electrons. As because it has 3 proton plus but 2 electron minus, so summation is it has 1 proton extra, and that is why this is the main reason that these lithium will behave like a cations. So it will be a lithium plus, because it has 1 proton more than electrons. But when a fluorine will accept these electrons. Why fluorine will accept these electrons? Because fluorine, we know that the atomic number of fluorine is 9, so it has 7 electrons in its outermost shell. So if we say that this 1, 2, 3, 4, 5, 6 and 7, if this donated electron comes here, and then what is happening? I mean, fluorine will have 8 electrons in its outermost shell that it was wanted. It was accepted. It was, waited for that fluorine was needed 1 electrons from anybody. So as lithium has given it, so fluorine will be negative, as because previously it has 9 proton inside, 9 proton, but after accepting 1 electrons, it becomes 10 electrons. So 1 electron extra, so it will be negative. So F becomes F negative. How? After accepting electrons. Li become Li plus. How? Because donating 1 electrons. When these 2 types of cations and anions comes together, then it becomes lithium fluoride. And this is an ionic compounds, because lithium fluoride was formed by accepting and donating same number of electrons by 2 atoms. Okay, if you say about magnesium oxide, or in case of lithium fluoride, what I can say, we usually expresses this like this. Like we can say that lithium becomes lithium plus after donating 1 electrons, and fluorine accept that electrons and become fluorine negative. So the equation is that lithium plus and fluorine minus comes together and formed lithium fluoride. So I hope whenever anything about this you should be able to write these equations like that. Even if you say about magnesium and chlorine, what about the magnesium? Now you think about magnesium has 12 atoms, 12 protons and 12 electrons. So it is 1s2, 2s2, 2p6, 3s2. So I hope you understand 3s2. So in case of chlorine, it has 17. So 1s2, 2s2, 2p6, 3s2, 3p5. Now you see that in the outermost shell of magnesium, it has 2 electrons. If it can donate, then it will have 8 electrons in its second shell, which is expected. But chlorine is just one electrons. One chlorine will need 1 electrons, but here magnesium is ready to donate 2 electrons. Then what will happen? So if magnesium donates these 2 electrons, so it is required to take 2 chlorines to accept these 2 electrons, and then another ionic bond will form. Like we can say that magnesium will be magnesium 2 plus by donating 2 electrons, and 2 chlorine will require to accept these 2 electrons, and then 2 chloride ions will form. So this is cation and this is anion. So what will be the equations? Like magnesium 2 plus and 2 chlorine minus will form MgCl2. This is very, very important. Do you understand really why MgCl2 will form, and this is magnesium chloride? Similarly, if you see, this is same in case of calcium and chloride. Calcium and chloride. If the question is show the bonding formation of calcium chloride, then we need to explain that calcium is becoming calcium 2 plus by donating 2 electrons, as because calcium is in the second group and the 4th period, so it has 2 electrons in its outermost shell and it will be donated. Then 2 chlorine atom is required to accept this 2 electron, and it will become 2 chloride minus. Okay, and then the equation is calcium 2 plus and these 2 chloride ions join together, and then they will form calcium chloride. I hope you understand how these things will happen. It's very easy. That you need to understand that how many electrons in the valence shell that is ready to donate or accept. So in case of fewer electrons like 1, 2 and 3, that group number 1, 2 and 3, they are metals and they will donate electrons and they will become positive ions and they will become cations. But here the non-metal group will accept the electrons based on their demand. Like calcium is donating 2 electrons, it doesn't mean that 1 chlorine need to accept these 2 electrons. I mean 2 chlorines are there to accept these 2 electrons, and the compounds will be calcium chloride. But what about calcium oxide? What about magnesium oxide? Like magnesium is donating 2 electrons and become magnesium 2 plus, but you see oxygen is ready to accept 2 electrons. So it will be easy. I mean, one atom can ready to donate 2 electrons and another atom is ready to accept the similar number of electrons. It's good. So we can say that magnesium is becoming magnesium 2 plus, by donating 2 electrons, and oxygen is accepting the similar number of atoms, ions, electrons is ready. So O2 minus, so is altogether it will be that magnesium 2 plus, so O2 minus will become magnesium oxide, which is very good. So this is magnesium oxide. What about the calcium bromide, or what about the zinc chloride, or what about zinc fluoride, what about the potassium chloride? All are same. Like in case of calcium fluoride, you can say that calcium is becoming calcium 2 plus after donating 2 electrons. Some people may have questions, like my students also may have questions. So can't we say that calcium is donating electron like these and calcium 2 plus? Of course, these are same. I mean, minus 2 electrons is becoming over there, so we just exchange the hand side, left hand side to right hand side, so it's become positive. So donating electrons could be this, like, so if in case of chlorine or fluorine, what is the main thing? Fluorine is 1 negative, that means fluorine is ready to accept 1 electron, but calcium is donated 2 electrons, so 2 fluorine is required. So 2 fluorine is required to accept these 2 electrons, and then it will become 2F minus, then it will be like calcium 2 plus 2F minus, and then it will form CaF2, which is the formula of calcium fluoride. So this is the ionic compounds formation process, and I hope you understand the process, like metal and non-metal. And simply you need to understand that ionic compounds will be formed in between metal and non-metal. And this is the process. Even you can have an idea like aluminium oxide. In case of aluminium oxide, what will be this scenario? So I'm deleting it. Okay. So in case of aluminium and oxide, what is the main part of it? You know, the aluminium, it has 3 electrons in its outermost shell. So aluminium is ready to give 3 electrons. But here in oxygen, oxygen can only receive 2 electrons in its outermost shell, and more than that it's not possible. So if aluminium wants to give 3 electrons, then how many oxygen will require to accept this amount of electrons? Let's see. If aluminium is donated aluminium 3 plus, so 3 electrons will never be accepted by 1 oxygen. So what can be done? Like 2 aluminium will be donated 6 electrons. 6 electrons. So I mean, if 1 aluminium can provide 3 electrons, then 2 aluminium can provide 6 electrons. So it will become like that. So 6 electrons like that. So now to accept these 6 electrons, we need 3 oxygen atoms. So we can say that 3 oxygen will accept these 6 electrons. 6 electrons. 6 electrons, and then it will become 3O2 minus. I mean O2 minus. Oxygen will receive these 2 electrons, but 3 oxygen is required. And now if you see the 2 aluminium 3 plus and 3 oxygen 2 minus will form aluminium oxide. And this is the chemical formula of aluminium oxide. I hope you understand. If the metal and non-metal, if the donated electrons and accepted electrons are not same, then we need to multiply it. And this is the formula of aluminium oxide. And this is about the ionic compounds and ionic bonds. I hope you understand. Just keep in focus on group 1, 2 and 3, that how many electrons they can donate and how many electrons can be accepted by the non-metal group, and then ionic compounds will be formed. And in case of your questions and in case of answering questions in your exam hall, you need to write these things like this. that how many electrons is donated, how many electrons is accepted, who is donating, who is accepting, and how it's formed. And the attractions in between these atoms or ions, you know, this is called cations and this is called anions. And you know that in between these cations and anions, the force is working is electrostatic attractions or Coulomb force, or you can say that this is electrostatic force. So this electrostatic force is working in between oppositely charged ions like this, and these ions are cations and anions. So I hope you understand. There is nothing remain but okay. And that is why I said earlier that each and every video has some limitations. I'm just trying to upload things properly, focusing on your books. I can go further explaining a lot of compounds right now, but I think there's something should be done by yourself. There's something should not be done by your teachers, as because teachers is only giving you the directions. I think you need to work with your own way. That is why I'm trying to upload things based on books, and so that I can make you clarify your concept, so that you understand the concept and you can do it by your own. And that should be the process and the purpose of education. So a teacher should not be completed your whole syllabus. I think from my side I'm doing it my best level, so make you understand. And of course, when you have more interactions with me, then I understand you well, that what you need more. So I hope you understand my explanations and these tutorials. And of course, I want your feedback upon my work, and do let me know what is the requirement. So thank you so very much in this very class, in this very beautiful class, ionic compounds. In the next class, I'm coming up with covalent bond and covalent structures. Take care, stay well, bye.